Hi students, welcome to Future Doctor Neet Academy for problem solving session in physics, Neet Physics. Yesterday we have given 7 questions in chapter 3, that is current electricity. Today we are going to discuss the problems, and also students are open to give their answer as an option in the comment section. Let's move to first question. The effective resistance of a series connection that consists of 4 wires of equal length, equal area of cross section, and same material is 1 ohm. What will be the effective resistance if they are connected in parallel? So that is the effective resistance for 4 resistor in serial connection is given as 1 ohm, and same resistor when it is connected parallel manner, then we want to find the effective resistance of the resistors. What is the answer? I found the answer. Option A, B, C, D. Which option? Students can say the option in the comment section. Is anybody giving option? Actually, no, neither A, B, C, D. Sometimes it may ask like this, that is an irrelevant question or wrong question or irrelevant data. In constant, some number may be missing, or in exponential form, some number is missing. In that condition, students can give, by attempting this question, students can get bonus mark. There will be a committee will be formed after NEET exam along with the experts, and then after discussion, who and all attended that question, bonus mark will be given. For just to aware about that bonus mark or wrong question, I have purposely given this question. Actually, correct option is in next slide, 0.0625. Let's discuss how we are getting this. So, effective resistance in series connection, that is series, or effective equal to 1 ohm. 1 ohm. For series, we know the formula. How many resistors are given here? 4 resistors. R1, R2, R3, R4. All are having equal. So, R effective equal to, you know the formula. R effective equal to R1 plus R2 plus R3 plus R4. As R1 equal to R2 equal to R3 equal to R4 equal to R. Then R plus R plus R plus R equal to 4R. 4R. And value is given R effective when it is connected in series as 1 ohm. Is it so? 1 ohm. So 1. Then R equal to 1 by 4 ohm. R effective, R equal to, not R effective, individual resistor, each resistor R value equal to 1 by 4 ohm. And question is, what will be the effective resistance when it is connected in parallel manner? So for parallel, this is for parallel. For parallel, what is the formula? 1 by R effective equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. 1 by R effective equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. As we know, R1 equal to R2 equal to R3 equal to R4 equal to just R. Then substituting this 1 by r plus 1 by r plus 1 by r plus 1 by r gives 4 by r equal to 4 by r. This is 1 by r effective. 4 by r. And we derived that r equal to 1 by 4. Just now only we found r equal to 1 by 4. Substitute this here. Then r as 1 by 4. 4 divided by 1 by 4 gives 4 into 4. 4 into 4, 16. 1 by r effective equal to 16. Then r effective equal to 1 into 16 or 1 by 16. 1 by r effective equal to 16. R effective equal to 1 by 16 or 1 into 16. Yes, correct. R effective equal to 1 by 16. That is equal to 0.0625. 0.0625 ohm. Ohm or omega. See, omega is the symbol for ohm. So, option A. Option A is the correct answer. Okay, let's move to next question. Second question. The resistance of a wire is Rho. If it is melted and stretched to n times its original length, its new resistance will be dash. Option A, B, C, D is given. I think anybody got answer for this? Your answer is displayed in black letter, black color as C. C, that is n square, or is the correct answer. I don't know how many of you got this answer. These are direct questions only, simple questions. That is, resistance of a wire is Rho, it's a given. And if it is melted and stretched to n times its original length, it means L2 equal to n times of L1. N times of L1. And whether stretching by increasing length or decreasing length by compressing, whatever, its volume is maintained constant. That is, volume V1 equal to V2. After stretching, that is a V2. Before stretching, that is the original volume V1. V1 is the initial volume and V2 is the final volume after stretching to n times. N may be some number. And we know the relation between volume and length. What is that? Volume equal to area of cross section into length. That is A1 L1 equal to A2 L2. From this A2 equal to A2 equal to A1 into L1 by L2. A1 by L2 into L1. Substituting the value of L2. This L2 here, 1 minute. I'll write this clearly. Substituting the value of L2, L2 equal to N L1, then equal to A1 into L2 is N L1 into L1. L1, L1 getting cancelled. Then A2 equal to A1 by L. A2 equal to A1 by L. We know the relation between resistance, length and area of cross section. That is, resistance R is proportional to length and inversely proportional to area of cross section, and also we may know R equal to rho into L by A. L is the length of the wire, A is the area of cross section of the wire, and rho. What is rho? Rho is a constant for a given material. What is rho? Rho is the density, that is the specific resistance. Rho is the specific resistance or resistivity, which is a constant for a given material. And R equal to will keep, as we are having two cases, that is initially one length and after stretching to n times another length. So first case we will write as L1 and A1, and resistivity or specific resistance is constant, whether stretching to n number of times or x number of times, whatever, resistivity is constant. And second case, R dash, when it is stretched to n times. When it is stretched to n times, then R dash equal to rho into L2 by A2. Now, substitute the value of this L2 equal to NL1 and A2 equal to A1 by N. That is this value and this value. This value we want to substitute that. Then this is equal to rho into L2 is NL1. N into L1 divided by A2 is A1 by N. A1 by N. N, when it comes up, comes as N into N square. That N square I am taking out. That is out of these formulas. That is R dash is equal to N square taken outside into remaining things. What is the remaining things? Rho into L1 by A1. Rho into L1 by A1. This rho into L1 by A1, that is equal to R. Then R dash is equal to N square. This rho into L1 by A1 equal to R. R dash equal to N square into R. That is option. Which option? Option C. Option C is the answer. Okay, I think you are very clear about this. Here, volume is maintained constant and length will be varying and area of cross section also will be varying. When length increases, area of cross section decreases and vice versa. Okay, let's move to next problem. Problem number 3. The mean free path of electrons in a metal is 4 into 10 power minus 8 meter. The electric field which can give on an average 2 EV energy to an electron in the metal will be in unit of dash volts per meter. First, we'll write the given data. What's the given data? Mean free path is given. That is lambda equal to 4 into 10 power minus 8 meter. 4 into 10 power minus 8 meter. And what's the other thing given? Energy is given. Energy is given and you want to find electric field also. Energy is given 2 EV. What is EV? EV is an electron volt. It is a unit of energy in atomic scale. Okay. Next, electric field you want to find. What's the symbol for electric field? That also E. So we may confuse with this E and that E. We may use this E as U or keep this as just E, and for electric field as like this. What is this? This is E vector because energy is a scalar and electric field is a vector quantity. So just to distinguish between this E as energy and this E as electric field, I keep as E vector. Then E vector equal to, what's the formula? E vector is equal to V by L or V by D or V by lambda as per this. Lambda is what is lambda? Lambda is a mean free path. What is mean free path? Is the average distance between the two successive positions of an electron. That is the mean free path. So it's a distance. So we can keep lambda as L. Is also equal to L. Okay. Energy is given. From this we want to find V, potential. What is the relation between E and V? That is energy E equal to E into V. Then V equal to E by E. So just divided by E. So what actually you want to do is 2 electron volt you have to convert into joules. That is 2 into 1.6 into 10 power minus 19. Then you will get in joules. And again divided by E. What is E? E is a magnitude of charge. That value is 1.6 into 10 power minus 19. So that E, this E getting cancelled. Directly I am saying as 2 EV, that E getting cancelled. Therefore, V equal to 2 volts. 2 EV equal to 2 volt. 10 EV equal to 10 volts. 20 EV, 20 volts. Directly we can apply. No need to convert into joules and then divided by 1.6 into 10 power minus 19. Because that E and divided by E both are same. Okay, so whatever, whenever E value, energy value given in electron volts, convert into volt directly by just 2 EV into 2 volts. Next, substitute this value here, come back here. E vector equal to V by L. Then substitute this here. V is 2 divided by L or lambda is 4 into 10 power minus 8. 4 into 10 power minus 8. Then, if you cross multiply this, 0.5. 4, 5, 20. So 0.5. 0.5 into 10 power minus 8 comes up 10 power plus 8. Then E vector equal to 0.5 into 10 power plus 8. 0.5 into 10 power plus 8. 1 minute. 0.5. Oh. 0.5 into 10 power plus 8. And answer is given in 10 power 7, 10 power minus 7 like this. So take 10 here as 10 power 1. 0.5 into 10 gives 5. 5 into remaining thing 10 power 7. Therefore, this is equal to 5 into 10 power 7. Okay, 5 into 10 power 7. Unit is given as volt per meter. So option D. Option D is the correct answer. Okay. We'll move to next problem, fourth problem. If a wire of resistance R is melted and recasted to half of its length, then the new resistance of the wire will be dash. Recasted means reshaping. That is, R is the actual resistance of the wire, and it's melted and recasted to half its length. Half of its length. Just previous only, second problem only we have discussed as R dash is equal to n times R or n square times of R. Yes, tell me. R dash equal to n times of R or n square times of R. Yes, it is n square times of R. Just we proved no. That is by maintaining volume as a constant. A1 L1 equal to A2 L2. From that we derived for A2 and L2 equal to n times of L1, and then by simplifying we got R dash equal to n square R. Here n is the number of times. N is given 1 by 2. n equal to 1 by 2. Substitute this here. Then r dash equal to n is 1 by 2. So 1 by 2 square into r. 1 by 2 square is 1 by 4. That is 1 by 4 of r. 1 by 4 of r or r by 4. So which option? Option A. So no need to keep as A1, L1, A2, L2 by keeping that, because already we derived, we know it's a known value, r dash equal to n square r. N is the number of times it's stretched or compressed. That is equal to, as per this, 1 by 2. So substituting this directly, you can get the answer. You got this answer. Okay. So option A is the correct answer. Next, we'll move to fifth problem. Two cities are 150 kilometers apart. Electric power is sent from one city to another city through copper wire. The fall of potential per kilometer is 8 volt and the average resistance per kilometer is 0.5 ohm. The power loss in the wire is dash. First we'll write a given data. What's the given data? Distance between the two cities is given, that is 150 kilometer. That is D equal to 150 kilometer. And then fall of potential is 8 volt per kilometer. V value, potential value, V value is given 8 volts per kilometer. And resistance is given, average resistance is given 0.5 ohm per kilometer. R value is given 0.5 ohm per kilometer. Then what you want to find? Power loss. Formula for power loss is in terms of V and R. Power loss equal to, actual main power equal to V into I. By substituting V or I in terms of R, we can get this, as per this, power loss equal to V square by R. Power loss equal to V square by R. And in two ways you can work out this problem. One is 8 volt per kilometer. Fall of potential is 8 volt for 1 kilometer. Then 8 volt for 150 kilometer. How much you will get? Fall of potential for 8 volt for 1 kilometer is 8 volt. And then when it is converted into 150 kilometer, for 150 kilometer, then multiplied by 150 or divided by 150. Same way, resistance 0.5 ohm for 1 kilometer. Then for 150 kilometer, multiplied by 150 or divided by 150. It's multiplied by 150 only. And so V is 8 into 150. Another one, R equal to 0.5 into 150. And after simplifying, you can substitute here. This is one way. Another way, directly you substitute this here. This is, I feel, this is the simplest way. Because 2 times you are substituting this 150 multiplied by 150 multiplied by 150. Instead of this, directly you can apply this and at last we can convert. That is, just you follow this. V is 8 volts. So, square of 8 square. 8 square divided by R. R is 0.5. 0.5. Then power loss is equal to 8 square is 64 divided by 0.5. To simplify this, multiply and divide by 10. Then you will get 640 by 5. Simplify this. Then 515 and 14, 5 to 10, 5 8 40. So power loss equal to 128 What's the unit of power? Unit of power is watt. This is for 1 kilometer because everywhere here is per kilometer. Now the question is for 150 kilometer, that is power loss for 128, power loss for 1 kilometer is 128 watts. Then for 150 kilometer, multiply by 150 or divided by 150. Is it divided by 150? No, multiply by 150. So that is equal to 128 into 150 gives 19,200 watts. This is power loss. 19,200 watts. Check it. No, it's in kilowatt. First we'll check in kilowatt. If you want to convert to kilowatt means divided by 1000. So this divided by 1000. Then how much will get? 19.2. That is power loss equal to 19.2 kilowatt. That is 19,200 divided by 1000. Then you will get 19.2 kilowatt. So option B. Option B is the correct answer. If you want to convert to megawatt, what you should do? Divided by 10 power 6. For kilowatt, 10 power 3. 1 kilowatt means 10 power 3. 1 megawatt, 10 power 6. Okay. Let's move to next problem. Sixth problem. The internal resistance of a 2-volt cell which gives a current of 0.2 ampere through a resistance of 10 ohm is dash. So here what you want to find? Internal resistance. Internal resistance denoted by a symbol small r that you want to find. And what's the given data? 2.1 volt cell. That is EMF. EMF E equal to 2.1 volts. And current I equal to 0.2 ampere. And resistance, total resistance R is given. R is given 10 ohm. You want to find internal resistance. What is the formula? Internal resistance E equal to I into R plus R. Capital R plus small r, or small r plus capital R, whatever. Here E is the EMF, I is the current, or capital R is the resistance, small r is the internal resistance of a cell. Here you want to find small r only. So simplify for first small r. That is I R plus I R. We want to find small r only. So keep I R one side and all the things through other side. That is I R equal to E minus I R. Now R only we want to find. So R equal to E by I minus I R by I getting cancelled. Therefore minus just R. Now you substitute the value. E is 2.1. 2.1. I 0.2. 0.2. And then minus R. Minus 10. Minus 10. To simplify this, as usual, multiply and divide by 10 here. Multiply and divided by 10. Then 21 by 2 equal to 21 by 2 minus 10. 21 by 2 is 10.5. So 10.5 minus 10. 10.5 minus 10. On it. 10.5 minus 10. 10.5 minus 10 is 0.5. So R equal to 0.5 ohm. So which option? Option B. Option B is the correct answer. Okay. Next problem. Last problem is a climax problem. A potentiometer consists of a wire of length 4 meter and resistance 10 ohm. It is connected to a cell of EMF 2 volt. The potential gradient of the wire is dash. First, as usual, we write a given data. Or the given data, length of the wire is given 4 meter. L equal to 4 meter. And then resistance is given 10 ohm. 10 ohm. And EMF or potential is given 2 volts. 2 volt. EMF or potential, that is 2 volt. Then potential gradient. What is potential gradient? Potential gradient means change in potential with respect to distance or change in potential with respect to length. Then potential gradient is V by L. That is nothing but electric field. And V by L or E by L. I said no, this is also equal to E by L. So EMF for potential will be same. E by L equal to E is 2 volts. 2 divided by L is 4 meter. Meter already in SI unit. So no need to convert. So by 4. Then 4, 5, 20. So 0.5. Therefore, V by L, that is a potential gradient equal to 0.5 volt per meter. Volt per meter. So which option? Option A. Option A is the correct answer. Okay. Okay, students, thank you. Thank you for watching this. You try to work out a problem like this. Similarly, tomorrow, same time, 12 p.m., I am going to give in unit 4 some 7 or 10 questions and try to solve it in next day. Next of the day, we will solve the problem that is a solution for the physics. Okay, thank you. Thank you, students.